Hi class, these are your 5.2 notes. At the end of class, the last time we met, we saw how the unit circle was derived, and we will spend more time on that in class when we meet next. But throughout these notes, we're using the unit circle to come up with certain values. So here it says, recall that the unit circle is a circle with a radius of 1 and whose center is at the origin of a rectangular coordinate system. On this unit circle, let theta be the angle of measure from the positive x-axis to the point xy. So what I'm saying there is that this is your theta, this is your angle. What we're going to do is we're going to look at the unit circle. So I'm going to bring it up. I'm just going to cover this. Maybe have your green unit circle out so you can reference it. I'm going to make it a little bit bigger so I can actually see things. All right. So it says if theta is 180 degrees, I just want you to give me the coordinate. So I look at 180 degrees. It looks like my coordinate for that is -1, 0. 270 degrees, it's 0, -1. 90 degrees is here, it's 0, 1. 360 degrees means I'm going around the circle one full time. So it's this coordinate. So it's 1, 0. 0 degrees is the same. Now negative, let me get rid of this stuff. Negative 90 degrees. Remember, we have to start here. And negative means we go in this direction and we stop at -90, so we stop right there. And so our coordinate is 0, -1. Okay, so now let's go ahead. I have this unit circle here so I can use it for later, but I'm going to move it. Just put it there for now. Okay, this is the really, really important stuff. We are on the unit circle, okay? That's the key thing. And what that means is when you're on the unit circle, that means your radius is 1 unit. So here I have just this random angle I'm choosing again, and I'm just going to go to the side. And, well, before I do that, I'm going to create that right triangle that we created in class. And I'm going to go to the side and draw that right triangle. Okay, and this is our theta. Well, this length from here to here, which is this length here on the triangle, that's my x value. And then when I move vertically up and down, that's my y value. And that's how we get that coordinate, which is right here, x comma y. And then this piece right here is known as our hypotenuse, but it's also known as the radius of our circle. And we know that our radius is 1. So if we're using some past definitions, so let's say I want to find sine of theta. Well, that definition is y divided by our hypotenuse, which I labeled r because it's the radius of our circle. But r, because we are guaranteed to be in the unit circle, is 1. So what we get here is we get sine of theta equals y, because y divided by 1 is just y. Where if I find cosine of theta, that definition is adjacent over hypotenuse. But in this case, my hypotenuse, because I'm guaranteed to be in the unit circle, is 1. So that's why it's just x. Now, this is only true when your hypotenuse is 1 and when you're in the unit circle. And so what's really special about this is this will always happen because you're always dividing by 1 in the unit circle. So for this coordinate, xy. Really, if you're in the unit circle, all of your x's are your cosine values, and all your y's are your sine values. Now, many students will get that mixed up because we're so used to finding those 6 trig functions. We find sine first, then we find cosine, then we find tangent. But just remember that your x's are always your cosines. Now, I'm just going to take a little time right here and just find tangent of theta. Well, tangent of theta definition is opposite over adjacent. So there, I could use the unit circle to also find tangent because I have my x and y values and I could just find the ratio of them. Okay, let's see if this makes sense. Now, if I'm looking, I have my unit circle here. It's covering up some problems, so maybe have your green unit circle out. I'm going to make this a little bit bigger so I can see things. Okay, so it says sine of 60 degrees. So I'm going to find 60 degrees, which is right there, on my unit circle. And hopefully the previous proof convinced you that, oh, okay, well, if 60 degrees, that means my sine is just my y value, so that's why this would equal root 3 over 2. And if you try this in your calculator and you do sine of 60 degrees, you will get out root 3 divided by 2. So now if I find cosine of 2 pi over 3, so I'm going to find that on my unit circle, so that's right there. Well, cosine are my x values, and so that's why that will equal negative 1/2. All right, let's move this guy. Sine of 360 degrees, remember that's 1 full revolution around the circle. My sine is my y value, and so that's why that's 0. Now it's switching up on us. It's saying 2 pi. Okay, well, I'm going to go around the circle 1 full revolution. And 2 pi is just using radians, and that's my x value. And so that's why that's 1. So maybe pause the video and see if you can do the rest of these values, and then come back and see if you got them correct. So I'm going to go ahead and get this stuff off, and I'm going to go ahead and move this guy. Okay, so sine of 3 pi over 2, I'm going to find 3 pi over 2, which is here. Sine is my y values, are my y values, so negative 1. Cosine of 270 degrees, that would be 0. I'm going to just put this down here. There we go. That'll make it easier. Sine of 45 degrees, it looks like that's going to be root 2 over 2. Cosine of 45 degrees, root 2 over 2. Sine of 90 degrees, 1. Cosine of 90 degrees, so again, just to refresh, we're looking here, that would be 0. There's that negative business, so negative. Start here and go in this direction. That's supposed to be a circle. And we want sine, so that's going to be negative 1 because it's my y values. However, cosine of negative 90 are going to be my x values, so that's why it's 0. So when I talked about in class that this will become, your unit circle will become your multiplication table in a sense in trigonometry, it's true. So if you have this memorized, by the end of this term, you're going to be able to tell me certain values very quickly. And no matter what, sine of 60 degrees, all of these values are always the same no matter if your radius is 1 or not, because the ratio will change depending on, the radius and your side lengths. The ratios will always be the same. Okay? All right. Bye-bye.